Question 1. What is 1,560,200 kilometers written in scientific notation correct to two significant figures? So I'm going to answer this question two different ways. The first way, the manual way, is to locate the most significant figure, which is the figure on the left-hand side here. So starting with the 1, this is the most important placeholder, the most important digit, because it represents 1 million. The next most important significant figure is the 5. So this represents the hundreds, the 100,000 place, or the hundreds of thousands. And the other digits are not significant. Now, the 6 here will cause the 5, this digit 5, to be rounded up to a 6. And the remaining digits then from the 6, 0 to 0, 0 will just become all zeros. So this becomes the number 1,600,000 or 1,600,000. And that makes sense since this number is pretty close to 1,600,000. Now the next step is we need to then express this in scientific notation. So starting off with the decimal point there on the right hand side, let's count how many decimal places we need to move it to get it between the 1 and the 6. So that's how we express a number in scientific notation. 1, 2, 3, 4, 5. There's 6 places there. Okay, so this will be 1.6. then multiplied by 10 to the power of 6. So it's going to be option D. Now, the other way to round a number and express a number in scientific notation at the same time is a nice option or mode on your calculator. Let me just brighten the camera a little bit there. Shift mode, and it sort of gives you a sort of a set of options there. Option 7, SCI. So that means scientific notation, but it also rounds to a certain number of significant figures. So select that. It'll then ask you for the number of significant figures. So press 2. Okay, and then we'll just type in this number, this ordinary number, 1,560,200. Now, if you press equals, it will round the number for you and write it in scientific notation or express it in scientific notation at the same time. So again, that confirms option D. Question 2. Which of the following is 4x plus 3y minus x minus 5y in its simplest form? So I'm going to suggest a strategy here to answer these questions a little bit more accurately, especially involving simplification in algebra. And that is to write the expression with gaps. So start off with the 4x. Now leave a gap and then write plus 3y. Leave another gap and write minus x. And then leave another gap and write negative 5y. So this is especially important if you're not feeling confident with algebra. This enables you then to collect the like terms far more effectively. So let's look at the like term involving the pronumeral x. So we have 4 of these x's minus x. When it's a pronumeral on its own, it actually means 1x. So 4x minus 1x is equal to 3x. And the y's, or the like terms involving the pronumeral y, we have positive 3y, or plus 3y, minus 5y. So 3 minus 5 is negative 2y. And looking at the options available, it's going to be option A. Question 3. Gail's gross pay each week is $952.25. The following deductions are taken from her gross pay each week. So we have tax, superannuation, union membership, and health fund. What is Gail's net pay each week? So the net pay is determined by taking all the expenses, or all the deductions, and then subtracting these amounts from her gross pay. So let's do just that. So 952.25 minus 180.93 minus 85.70 minus 21.40 minus 38.15, and we have $626.07. So it's option B. Question 4. On a school report, a student's record of completing homework is graded using the following codes. So we have CUSRN, which stands for consistently, usually, sometimes, rarely, or never. What type of data is this? So in statistics, we can classify our data as either categorical or quantitative. It either involves numbers or it involves descriptions, qualities. So clearly no numbers are involved there, so it's neither C nor D, so it's not quantitative. It's categorical, but are the categories able to be ranked or placed in some order? And clearly there is an order here that we can use. So consistent could be the highest, usually sort of the next highest, so on and so on to never. So this can certainly be ranked, which means it can be ordered. And there's a word here which resembles the word order, which is the word ordinal, which means ordered or ranked. So it's option A. Question 5. Which of the following graphs best represents the equation y equals x cubed plus 1? Let's have a look at the 4 graphs. Let's have a look at option A. A straight line is represented by an equation which resembles y equals mx plus c. Let's have a look at option C. This is a graph that is exponential. In other words, it starts off sort of a very low values sort of very low values here, very close to the x-axis on the left-hand side. And as you move from left to right, the graph gets sort of steeper and steeper and higher. The values of y, the vertical values, just start increasing, in fact, at an increasing rate. So this could be the function y equals 2 to the power of x, the equation y equals 2 to the power of x. Option D. This is like a U shape. Okay, we give those a name. There's a very special name for that, which is a parabola. It could be sort of a concave, what we call concave up or concave down, where it's sort of a sad face, sort of happy face type scenario. This one's a happy face. This one is of the form something that involves an x squared plus c. So none of these 3 options, in fact, resemble the equation in the question. X cubed gives you a characteristic, almost like an S or a Z shape if you turn the graph on its side. So turn it that way. You can see kind of what resembles like a letter Z. Anyways, move it back the right way. So it's clearly this one here. This one is y equals x cubed plus 1. 1 is the y-intercept. So it passes through the y-axis at y equals 1. So it's option B. Question 6. The times in minutes that a large group of students spend on exercise per day are presented in the box and whisker plot. What percentage of these students spend between 40 minutes and 60 minutes per day on exercise? So a box and whisker plot divides the data into quartiles, but it's just represented graphically. So 25% spend between 10 and 40 minutes. Another 25% spend between 40 and 60 minutes. Another 25% between 60 and 90 minutes. And the top 25% spend between 90 and 120 minutes. So between 40 and 60, we have 25%. And that's option C. Question 7. The diagram shows a radial survey of a field ABCD. In triangle AOB, what is the size of angle AOB? So first step, let's locate triangle AOB. So there's AOB, so it's this north-facing triangle. Angle AOB is this angle here. Okay, this is where ray OA and OB come together, okay, at the vertex. So the angle we want is this angle here. Now, there's 2 ways we can do this. One way would be to find this angle here, this angle there, and this angle here, and then add them together and subtract it from 360 degrees, and that could work, okay? and that'll give you angle AOB. Or we could use the fact that to go from point A and rotate clockwise to north, so 300 to north, which is 360 degrees, we need to move or rotate another 60 degrees to get to north. Once we get to north, to rotate from north then to point B, it's like we're starting from 0 again. So 0 and 360 degrees are kind of the same thing, really. It's just sort of, you do one rotation around, you get to 360 degrees, and then it sort of starts again, kind of like a clock, isn't it? It goes back to 12 o'clock again. So from north to point B, okay, B is on a bearing of 51 degrees, or 0.051 degrees. So that angle is 51 degrees. And the sum of these two angles there, because they're adjacent angles, then gives you the size of angle AOB. So angle AOB is equal to 60 degrees plus 51 degrees, which is equal to 111 degrees. And that's option B. Question 8. The Louvre Pyramid in Paris has a square base with side length 35 meters and a perpendicular height of 22 meters. What is the volume of this pyramid to the nearest cubic meter? So first of all, we know it's a pyramid. Okay, we're told that. And the formula for the volume of any pyramid is V equals 1/3 multiplied by the area of the base multiplied by the height. Now, this is a square-based pyramid. Okay, we're sort of told that in the question, so you can underline that if you like. So we could just apply or substitute in the numbers or the values into the formula. So we have 1/3 multiplied by A, which is the area of the base. Now it's a square, so the area of a square is 35 multiplied by 35. And then we're going to multiply it by the perpendicular height, which is 22 meters. And multiplying all that together. Okay, so we have 1/3 multiplied by 35 multiplied by 35, or 35 squared, of course, whichever's quicker. And press the SD button, we get 8983. So it's to the nearest cubic meter. 8983 cubic meters. So that's option C. Question 9. From the top of a cliff 67 meters above sea level, the angle of depression of a buoy is 42 degrees. How far is the buoy from the base of the cliff to the nearest meter? Now, one thing to note is that the angle of depression is equal to the angle of elevation, because they are alternate angles. So this is the angle of depression. The angle of elevation is in fact identical. So we can use that instead. So we can see here we have a right angle triangle. Okay, we have an opposite side, but we need the adjacent side. So I might just put a letter X there to represent the adjacent side. So we want how far the buoy is from the base of the cliff, and using our right angle trigonometry, or right angle triangle trigonometry, we have an opposite adjacent side from SOHCAHTOA. That's going to be the tangent ratio. So tan of 42 degrees is equal to opposite 67 over adjacent. Okay. When we have the unknown in the denominator, we can just swap the denominator with the trigonometric ratio. So leave the 67 in the numerator and we'll put tan 42 in the denominator. Let's quickly work that out. 67 over tan of 42 degrees, and we have 74.4 meters. Okay. And the answer that's closest to that is option B. Question 10. A piece of machinery initially worth $56,000 depreciates at 8% per annum. Which graph best shows the salvage value of this piece of machinery over time? So salvage value means the value of that item at any point in time. So it's a value you can salvage, basically, is what it's called, salvage value. So if you were to sell that item or that piece of machinery in 5 years' time or in 10 years' time, what would it be worth? Kind of like its resale value. Now, it's depreciating at 8% per annum, so this is declining balance depreciation. So I might just write that here, declining balance. Okay, as opposed to straight line depreciation. So it's certainly not option D, because that's a straight line method of depreciation. This piece of machinery, it could be a motor vehicle, for example. The depreciation is quite steep initially, but then it sort of tapers off, and it will never, ever reach zero according to this method of depreciation. So it can't be B. Okay, so graph B shows that the value will eventually be zero. That's not right. And option C shows the value dropping gradually in the beginning, but then the value starts to drop off quite steeply in the end until it reaches zero. Again, that doesn't happen, well, at least not in theory. It's option A. Okay, so just like I guess a car, when you buy a brand new car, as soon as you drive it out, the depreciation is quite steep in the beginning, and then it starts to shallow out. And that's 30 years later, it gets closer and closer to the x-axis, sort of an asymptote of sorts, but never actually quite reaches it. So this is the graph that best describes that. Question 11. Which of the following is 3x to the power of 0 plus 5x in its simplest form? So to help answer this question, I'm going to expand this expression by including the multiplication symbols. So 3x to the power of 0 is just 3 multiplied by x to the power of 0 plus 5x. So that's really just 5 multiplied by x. Now, index laws. Anything to the power of 0, apart from 0 itself, of course, but anything to the power of 0 is 1. So this is equal to 3 multiplied by 1 plus 5 multiplied by x. And we can now simplify this. So 3 times 1 is just 3, and 5 times x is 5x. So 3 plus 5x is the expression in simplest form, option D. Question 12. The length of a fish was measured to be 49 centimeters, correct to the nearest centimeter. What is the percentage error in this measurement, correct to one significant figure? The first thing we need to do is to find the precision. How precise is this measuring instrument? And that is given by the smallest unit it can measure. It looks like it measures in lots of, well, in centimeters or in whole centimeters. So that would be as precise as this instrument can get. So it measures correct to the nearest centimeter. So that's its precision. Now the next thing we need is its absolute error, which is half the precision. So that's going to be 0.5 centimeters. Now the next thing we need is now the percentage error. Well, to calculate that. So we take the absolute error. So this is the percentage error now, is equal to the absolute error, 0.5, over the measurement itself, which is 49 centimeters, and we multiply that by 100, of course, because it's a percentage. Okay, so let's enter that in now. 0.5 over 49 multiplied by 100, and we have 1.020, so it's 1.020 ... and that's a percent or percentage. So correct to one significant figure, it's 1%. So it's going to be option C. Question 13. What is the equation of the line L? So this is this line here. First thing we need is to find the y-intercept. That's the easiest thing. Y-intercept is 2. Okay, so this is going to be in the form y equals mx plus c. And we have found the y-intercept, so it's y equals mx plus 2, okay? But we need the gradient as well. Now, going from left to right, or moving sort of from left to right, the line is starting up high and ending up a lot lower. So it's a negative gradient. So it's certainly not option B, and it cannot be option D. Both option A and option C have negative gradients. So gradient is equal to rise over run. And we can use this right angle triangle here to help us determine that. Now the rise is a negative rise. So starting at 2 ending at 0. So it's actually dropping 2 places. So represent that with a negative 2 over a run of 1. And that's equal to negative 2. So the equation is y equals mx plus c negative 2x plus 2. And that's going to be option A. Question 14. Stockholm is located at 59 degrees north, 18 degrees east, and Darwin is located at 13 degrees south, 131 degrees east. What is the time difference between Stockholm and Darwin? Ignore time zones and daylight saving. Now, the first thing to note is that time difference has nothing to do with lines of latitude or parallels. These are the first numbers, or the first in these pair of coordinates. So you could in fact cross these out. So the 59 degrees north, 13 degrees south has nothing to do with time difference. It's purely the difference in longitude, or the difference in the meridians. Now the next thing I'm going to do is to draw a number line to visualize this. Okay, so let's make this 0 degrees, so that's our prime meridian. Stockholm is 18 degrees east, so there's east and west, so I'll just mark that on the number line. Okay, so there's 18 degrees, okay, and that's Stockholm. And Darwin, okay, is 131 degrees east. So that would be here, 131 degrees east, and that's Darwin. So let's work out, first of all, the difference in longitude. Okay, so Stockholm is closer to the prime meridian. Okay, that's the meridian that runs through England, or not far from London, actually through a town called Greenwich. That's what's used to be called Greenwich Mean Time, GMT. Okay, so 131 minus 18 gives us 113 degrees difference. Now, it's well worth noting, if you haven't worked this out, or you could work this out if you like manually, but I guess it's just well worth remembering this one. Every 15 degrees difference in longitude is equal to 1 hour. So the time difference will be 113 degrees. Now divide that by 15, because every 15 degrees is equal to 1 hour. And let's see what we get there. So 113 degrees divided by 15, and we get 7.5333. In fact, let me just convert that into a fraction. So it's 7 8/15 of an hour. So equal to 7 8/15 of an hour. Now, in minutes, okay, we could multiply that by 60. And we get 452 minutes. Okay. And there is an option for that, which is option C. Question 15. A camera costs $449, including 12% GST. What is the price of the camera without GST, correct to the nearest dollar? So notice first of all that it's not 10% GST, so we can't do the whole divide by 11 or those sort of shortcuts. But a good way to think of it is like this. We have the camera, and we're going to add 12% GST, so we're going to multiply it by 112%, so that increases it by 12%, and we get $449. Now let's reverse that. We want the price of the camera before the GST is added. So camera is equal to 449 divided by 112%. Okay. Divide that by 112%. And we get $400.89. Which to the nearest dollar is option B. Question 16. The probability of winning a game is 7/10. Which expression represents the probability of winning 2 consecutive games? This is the multiplication principle in probability. I might just quickly demonstrate this using a tree diagram. Okay, so win, lose, win, lose, win, lose. And we want to win 2 consecutive games. So if the first game, the probability of winning is 7 on 10 or 7 over 10, winning the second game is also 7 over 10. Winning both games in a row is 7 over 10 multiplied by 7 over 10. And it's going to be option D. So you don't have to actually work out or evaluate it, just the expression is all you need. Question 17. What amount must be invested now at 4% per annum compounded quarterly so that in 5 years it will have grown to $60,000? So this is a compound interest problem. So present value, future value, and in fact I might just write the formula quickly, is equal to present value 1 plus r% to the power of n. So there's the interest rate per period and the number of periods. Now, we have 4% per annum compounded quarterly, so the R is in fact equal to 1% per quarter, and the N is the number of quarters. We have 5 years worth, 4 quarters a year, we have 20 quarters. So we have a future value, which is $60,000, so we want to work out the present value. 1 plus 1% to the power of 20. Now let's solve this equation for the present value. So 60,000 over 1 plus 1% to the power of 20 is equal to the present value. Okay, so let's enter that in now. 60,000 over 1 plus 1% to the power of 20, and we have $49,172.67. And the closest option to that, so it's to the nearest dollar, is option C. Question 19. The table shows the life expectancy, expected remaining years of life for females at selected ages in the given periods of time. In 1975, a 45-year-old female used the information in the table to calculate the age to which she was expected to live. 20 years later, she calculated the age to which she was expected to live. What is the difference between the two ages she calculated? So in 1975, the age at which she was expected to live would be her current age, or the age in 1975, which is she was 45 years of age, and she was expected to live another 34 years. Okay, so 5 plus 4 is 9, 4 plus 3 is 7. Okay, so that's 79 years of age is the expected age which she's going to live to. 20 years later, so this is 1995, so using this row here, okay, she's 65 years of age by then, so adding another 20 years. And she's expected to live another 19.8 years. Okay, so that takes it almost to 85 years of age, so that'll be 84.8 years. Okay, and the difference will be, okay, so if you don't trust yourself, you can always just use your calculator. Make sure you don't make a mistake here. It'll be 5.8. Okay, so difference is 5.8 years. Option D. Question 20. A machine produces cylindrical pipes. The mean of the diameters of the pipes is 8 centimeters and the standard deviation is 0.04 centimeters. Assuming a normal distribution, what percentage of cylindrical pipes produced will have a diameter less than 7.96 centimeters? So this is a question based around the bell curve, around the normal distribution. Now it's interesting to note that 7.96 centimeters is one standard deviation below 8 centimeters. In other words, its Z-score is -1. Okay, and that's actually easy to work out. First of all, let's quickly do that. Z score is equal to 7.96, the raw score minus the mean over the standard deviation over 0.04. Okay, and if you want to quickly work that out, 7.96 minus 8 over 0.04, and we have a Z score of -1. Okay, so you can refer to the formula sheet, but I'm just going to draw just a bell curve here quickly. Okay, so there's a Z score of 0, which represents the mean. Okay, that's the mean of 8 centimeters, so that's Z. And here's a Z score of -1. Now, we know that 50% of the scores lie basically on, it's sort of in each half of the bell curve, either side of this Z score of 0. We also know that between -1 and 0, we have 34% of the scores, which leaves the balance of 16% of scores that lie basically from -infinity, sort of all the way to one end of the bell curve, to a Z score of -1. And this -1 refers to, or is represented by 7.96 centimeters. So the answer is A, 16%. Question 21. 4 cards labelled 2, 3, 5 and 7 are placed on a table to form a 4-digit number. How many different numbers greater than 3,000 can be formed? So that means that the number can't start with a 2, but it can start with a 3, since if the first digit's a 3, the next digit can either be a 2, 5 or a 7, so it's clearly going to be over 3,000. So we have 3 different possibilities. So if the number begins with a 3, let's say, so I might just cross that out there. So let's choose 3, okay, as our first choice. We then have 3 more numbers to pick from. So in the 3,000s, we got a choice of 3 to begin with. So the next digit could be a 2, 5 or a 7. So pick one, you have 2 left. Pick the second one, you then have 1 left. There's 6 different ways. Now let's have a look at the 5,000s. So the numbers beginning with 5, 4-digit numbers beginning with 5. Again, same thing. We've taken out the 5, we've now got 3 left. So you choose one, and then you have 2 left. Choose another one, you have 1 digit left, and you only have a choice of 1, and that gives us another 6 ways. And then lastly, we have the 4-digit numbers beginning with 7. So if you choose the 7, right, you choose the 7, you have 3 digits to pick from. Choose one of those 3 digits, you then have 2 digits to pick from, and then once you choose one of those, you have, like your last digit, well, there's only a choice of 1, and that also gives us 6. Total, 18 different numbers. So option C. Question 22. The area of the triangle shown is 250 square centimeters. What is the value of x correct to the nearest whole number? Now, given that we have the area of the triangle, we don't know what the perpendicular height is. This is an application for the sine rule for the area of a triangle. This is the half AB sine C. So let's use that. So we know that the area of the triangle is 250 square centimeters, is equal to half AB sine C. So this can be A, this can be our B. So half multiplied by 30 multiplied by x multiplied by sine 44 degrees. Let's rearrange this formula now to find x. So leaving the 250 where it is, moving the half over, we're going to divide by half, then divide by 30, and then divide by sine of 44 degrees, and that gives us x. So let's enter that in and see what we obtain. So 250 divided by half, divided by 30, divided by sine of 44 degrees, and we get 23.99, which is equal to 24, correct to the nearest whole number, option D. Question 23. The number of standard drinks in various glasses of wine is shown. A woman weighing 62 kilograms drinks 3 small glasses of white wine and 2 large glasses of red wine between 8 p.m. and 1 a.m. What would be her blood alcohol content BAC estimate at 1 a.m. correct to 3 decimal places? Now, in order to answer this question, the formula does need to be given. Now, in the old syllabus, the formula was in the formula sheet, so that would have been it there. Okay, so I've just copied it out here in the question. In the current syllabus, the formula is generally given to you, so it's just more a matter of how to use the formula. Okay, so let's do that. Now, the M is the mass, so we know that M is 62. H is the number of hours drinking, and so I might just write these down. So M is equal to 62. H is the number of hours drinking, and that's between the hours of 8 p.m. and 1 a.m. So 8, 9, 10, 11, 12, 1, there's 5 hours, so H is 5. But the N is an interesting one. So the number of standard drinks, and this is where we need to consult the table. So 3 small glasses of white wine. So we're using this column here, and there's 3 of those. And we have 2 large glasses of red wine. Okay, so 2 large glasses of red wine, so 2 of those. So N is equal to 3 lots of small glasses of white wine, so that's 0.9, plus 2 drinks, 2 large glasses of red wine, so two of those drinks, and each one of those is 1.5 standard drinks, so that needs to be in brackets. Now let's enter that into the formula, so substitute those values into the BAC formula, and let's see what we get. Okay. So 10n, actually I might just enter it in as a fraction. Yep, I might just brighten that a little bit. Yep, that's better. Okay, so 10n, so that's the n there. So 3 multiplied by 0.9 plus 2 multiplied by 1.5, close brackets. Okay, minus 7.5h, so 7.5 multiplied by the number of hours drinking, so that's 5, over 5.5 multiplied by her mass, which is 62 kilograms, and we get 0.0572, or 0.057 to 3 decimal places. So 0.057 ... and answer is option D. Question 24. Consider the equation 2x on 3 minus 4 equals 5x on 2 plus 1. Which of the following would be a correct step in solving this equation? Now, typically when solving an equation that has a variable or an unknown variable on both sides of the equal sign, I guess it's not necessarily the only way to think of this, but generally convention, or by convention, we like the pronumerals on the left-hand side and the constants eventually migrating over to the right-hand side. So leaving the 2x over 3 where it is, okay, the negative 4 probably should move over to the other side. So equals 5x over 2 plus 1. So that's the plus 1 there. But negative 4, when it moves over to the other side, becomes positive 4. Okay. So think of the opposite of left is right. The opposite of minus 4 is plus 4. So 2x over 3 equals 5x over 2 plus 1 plus 4 is just plus 5. And in fact, there's only one of these options that has a plus 5 in it. There's a 2x over 3, which is there, so that's on the left-hand side. 5x over 2 on the right-hand side. 5x over 2 on the right-hand side. I think we can safely say it's option B. Question 25. An insurance company offers customers the following discounts on the basic annual premium for car insurance. So here's the schedule there. If a customer is eligible for more than one discount, subsequent discounts are applied to the already discounted premium. The combined compulsory third party CTP and comprehensive insurance discount is always applied last. Jamie has 3 insurance policies, including combined CTP and comprehensive insurance with this company. He has used this company for 8 years and he has never made a claim. The basic annual premium for his car insurance is $870. How much will Jamie need to pay after the discounts are applied? Alright, so there's quite a bit going on here. And this is certainly a multiple choice question that you do not want to rush. So spend a little bit of extra time where need be. Okay, so, and it's actually not as difficult as all that. Let's start. So we have $870 and obviously that's going to be discounted. Going backwards, okay, we know that he used the company for 8 years. Okay, so clearly this no claim bonus will be applied since he's also never made a claim. So both of these apply there. So there's going to be a 20% discount. And he has a multi-policy discount as well. Has 3 insurance policies. So that means that this applies as well, this 15%. Okay. And subsequent discounts are applied to the already discounted premium. All right, so let's start. We have $870. Okay, we're going to discount that by 15%. And the way we're going to do that is we're going to multiply it by 85%. Okay, so just to show you how this works, think of it this way: 100% minus 15%. Okay, and then we're going to discount it again, multiplied by, okay, we're going to discount it by 20%, so we're going to multiply it by 100% minus 20%. There's a shortcut to this. I'm just sort of showing you the long way of doing things, just so you can understand what I'm doing here. Okay, so this is a reduction or a discount, and then we're going to subtract $50. Okay, so $50 discount. So minus $50. Let's see what we get. Okay, so 870. Now, rather than typing all that out, I'm just going to type in 85%, just a bit quicker. Then we're going to discount it by 80%. Sorry, by 20% by multiplying by 80%. Sorry. So shift percent there. So multiply by 85, multiply by 80, and we're going to subtract $50, and we get $541.60. Okay. 541.60, and that's option C. Question 26A. A farmer used the recapture technique to estimate the number of chickens he had on his farm. He captured, tagged, and released 18 of the chickens. Later, he caught 26 chickens at random and found that 4 had been tagged. What is the estimate for the total number of chickens on this farm? So we could express this in the form of equivalent ratios. So we're trying to estimate a population of chickens, so let's call that population P. And of that population, the farmer tagged and then released 18 of them. Later on, okay, 26 chickens were caught, of which 4 had been tagged. Now we can express this in fraction form, and that certainly makes it easier to solve for P. So P over 18. So ratios and fractions are can be almost treated the same way, almost, is equal to 26 over 4, multiplying both sides by 18. So moving this division by 18 over to the other side becomes multiplication. So P is equal to 26 over 4 multiplied by 18. Okay, and let's see what we get. So 26 over 4 multiplied by 18, and we get 117 chickens. Question 26b. Clark's formula is used to determine the dosage of medicine for children. So you've got dosage equals weight in kilograms multiplied by adult dosage all over 70. The adult daily dosage of a medicine contains 3,150 milligrams of a particular drug. A child who weighs 35 kilograms is to be given tablets, each containing 525 milligrams of this drug. How many tablets should this child be given daily? So this is just an example of just applying the formula directly. Okay, we have the weight in kilograms, so that's 35. So I might just write them there. We have the adult dosage, okay, which is 3,150. Okay, so let's work out what the dosage is that's required for this child. And we also know that each tablet is 525 milligrams. So it's how many tablets should this child be given daily. So dosage, okay, is equal to 35, okay, 35 kilograms multiplied by 3,150 milligrams of the drug over 70, okay, and that gives us 35, actually I'll enter in as a fraction directly, 35 multiplied by 3,150 over 70, and we get 1,575 milligrams, okay, 1,575. Now, the number of tablets, okay, so is equal to 1,575 milligrams. That's the total dosage, but each tablet is 525 milligrams. So dividing that by 525, okay, and we get 3. So answers 3 tablets. Question 26C. 2 cities lie on the same meridian of longitude. One is 40 degrees north of the other. What is the distance between the 2 cities, correct to the nearest kilometre? And assume that the radius of the Earth is equal to 6,400 kilometres. Now, first thing to note is that a meridian, or a meridian of longitude, is a great circle. So it's the circle of greatest circumference that really wraps around the Earth. And the radius of that circle is 6,400 kilometers. So the distance is going to be 2 pi r, so the circumference formula, okay, multiplied by 6,400 kilometers. But what fraction of the circle are we talking about? We're talking about 40 degrees out of a total of 360 degrees around a full circle. So we need to also multiply that by 40 over 360. Okay, it says to the nearest kilometre, so just keep that in mind. Okay, so 2 pi multiplied by 6,400 kilometres. Okay, so that little detail needed to be given there. So in the old syllabus, or the previous syllabus, that was I think that was supplied in a formula sheet. So I think to answer this question in the current syllabus, we need to be given some details. Okay, and we get 4,468 kilometers to the nearest kilometer. Question 26D. A family currently pays $320 for some groceries. Assuming a constant annual inflation rate of 2.9%, calculate how much would be paid for the same groceries in 5 years' time. So this is an application of, in fact, of compound interest, even though it's a different context. So we're using it in the context of inflation, but it works very similar to compound interest. We actually use the compound interest formula, which is future value is equal to the present value multiplied by 1 plus r to the power of n. So the present value is the current value of the commodities, so of these groceries, so $320. We want to find out obviously how much they're going to be worth in 5 years' time. So it's 1 plus, now it's being inflated by 2.9% per annum. Okay, so think of it as an increase in value or increase in price, anyway, to the power of 5. Okay, and entering that expression in the calculator. So 320 outside of 1 plus 2.9%. Okay, you don't need to write this as a decimal. You can just type in 2.9%. So I know some students, for example, they go, oh, what's 2.9% as a decimal? With these calculators, there's no need to bother. Just type it in as is. Okay, so it equals $369.17. Okay. And that would be the price of those same groceries in 5 years' time. Question 26E. The table shows the relative frequency of selecting each of the different colored jelly beans from packets containing green, yellow, black, red, and white jelly beans. Part 1. What is the relative frequency of selecting a red jelly bean? So relative frequency is basically the probability, but obviously determined experimentally, the sum of all the probabilities of all the possible outcomes should equal 1. So 1 minus 0.32 minus 0.13 minus 0.14 minus 0.24 should then give us the probability of red. So 1 minus 0.32 minus 0.13 minus 0.14 minus 0.24, and we get 0.17. And I might just fill that in the table here as well, just for completeness. Part 2, based on this table of relative frequencies, what is the probability of not selecting a black jelly bean? So this is an example of complementary probability. So the probability of not selecting a black jelly bean is the opposite of selecting a black jelly bean, or the complement of selecting a black jelly bean. So that's going to be 1 minus the probability of selecting a black jelly bean. And that's 0.14. So 1 minus 0.14 will give us the probability of selecting everything else. And that's going to be equal to 0.86. Question 26F. Approximately 71% of Earth's surface is covered by water. Assume Earth is a sphere, and also assume that the radius of the Earth is 6,400 kilometers. So this is a question again from an older syllabus where the radius of the Earth is in fact stated in a formula sheet. We don't state that or even use that in a formula sheet in the current syllabus. Generally, something like this is normally given or may be given in a question. So I'm going to give it here. Calculate the number of square kilometers covered by water. Okay, so the formula for the surface area of a sphere. Okay, we can use the current formula sheet here from NESA. This is the 2020 formula sheet. In the section here where it says surface area, it's this one here. A equals 4 pi r squared. Okay, so let's use that. So area is equal to 4 pi multiplied by r squared, so that's going to be 6,400 squared, but we want 71% of that, since that's what we're asked for in the question. The percentage of Earth's surface that's covered by water is 71%. Okay, and let's multiply all of that together and see what we get. So 4 pi, okay, multiplied by 6,400 squared, multiplied by 71%. Okay, and we get a fairly big number. Okay, so that's equal to, I might just write this down, 365,450,163.7. Okay, square kilometers. If you wanted to round that, say, to so many significant figures and use scientific notation to express the answer, in the NESA solution, it's expressed in scientific notation. This is sort of more the exact solution, but if you wanted to round this to, say 2 significant figures and in scientific notation or in standard form, let's have a look and see how we do this. Let's look at the decimal point. Let's move the decimal point back so that it's between the 3 and the 6. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to write this then as 3.7. So that 6 gets rounded up to a 7, multiplied by 10 to the power of 8, since that's the number of places I've moved the decimal point to get it between the 3 and the 6, square kilometers. Question 26G. Pat's mobile phone plan is shown. Last month, Pat made calls to the value of $561, sent 152 SMS messages, sent 37 MMS messages, and used 1.7 gigabytes of data. What was the total of Pat's phone bill for last month? So I think the first thing to note, looking at the bill, that Pat doesn't get charged for SMS or MMS messages. So really, we can just ignore these two lines. So it's really just the phone calls, okay? In fact, we've got that there to add as well, which is the monthly fee, the base fee for the mobile phone plan. So it's $49 per month, but we need to add on a little bit extra here. So pay any amount in excess of $550 for the calls, and we've got 561 here. So for the calls, okay, we have 561 minus 550, so that gives us $11 worth of calls that Pat will need to pay for. The other thing that we need to consider is the use of data. So let's work out how much data was used first. Okay, so usage is equal to, now we need to convert this into megabytes. So it's 1.7 gigabytes, and we multiply that by 1024. Okay, and okay, now that will give us 1740.8 megabytes. Yeah. Okay, so the excess usage is equal to 1740.8 minus 500 megabytes. Okay, so we'll subtract 500 from that, and we get 1240.8. Okay, so the data charge, okay, or the data cost, okay, is 1240.8, and it's going to be charged at $0.0293 per megabyte. 0.0293 to is it 9 to make sure I get this right? 293. Yeah. And we get $36.36 rounded to the nearest cent. Okay, so that's equal to $36.36. So the total phone bill, okay, is going to be equal to the standard monthly cost of $49 plus the calls, $11, plus the data cost, $36.36. Okay, adding all that together, so 49 plus 11 plus $36.36, we get $96.36. Question 27A. At a particular time during the day, a tower of height 19.2 meters casts a shadow. At the same time, a person who is 1.65 meters tall casts a shadow 5 meters long. What is the length of the shadow cast by the tower at this time? So this is a question that's based around similar triangles, and I want you to notice here we have the large right angle triangle, okay, and that is similar to the small right angle triangle. What that means is that the corresponding sides are all in the same ratio. But it also means that sides relative to each other are also in the same ratio. So in other words, 1.65 to 5, so let's write this ratio down. 1.65 to 5, and I'll write it as a ratio, so using the correct notation, is equal to 19.2 to this sort of the length of the shadow. So 19.2, let's call it x. Okay, so let's call that the length of the shadow x. So let's solve this. 1.65, we will solve it by treating the ratio as a fraction. 1.65 over 5 is equal to 19.2 over x. Now, the x is in the denominator. When you're trying to solve for a pronumeral, it's nice to have that in the numerator. So we can, in fact, we could flip both these fractions. So why don't we do that? So in other words, 5 over 1.65 is equal to x over 19.2. What you do to one side, you do to the other. Okay, so if you invert both fractions, you haven't changed the integrity of the equation. I mean, the left-hand side still equals right-hand side. Now let's make x the subject of the formula. We're going to move the 19.2 over to the other side. So let's do that. So 19.2 multiplied by 5 over 1.65 is equal to x. So let's evaluate the left-hand side. I'll just brighten the display a little bit there. Okay, so 19.2 multiplied by 5 over 1.65, and we get 58.18. So okay, and let's see if there's any rounding required. No rounding required, so we could leave it to correct to 2 decimal places. Question 27b. A patient requires 2,400 milliliters of fluid to be delivered at a constant rate by means of a drip over 12 hours. Each milliliter of fluid is equivalent to 15 drops. How many drops per minute need to be delivered? So let's work out the number of drops or number of drips in total. We have 2,400 milliliters, of which each milliliter is 15 drops, or is equivalent to 15 drops. So the number of drops, okay, in total is equal to 2,400 milliliters. So that's the total amount of fluid to be delivered, multiplied by 15, and that equals, okay, so 2,400 multiplied by 15, we have 36,000 drops. So, and that's over a 12-hour period. Okay, so we have 36,000 drops. So we'll express this as a rate per 12 hours. But we need this per minute. So let's divide everything by 12, both terms by 12 to get it per hour. Okay. So 36,000, divide that by 12, so we get the number of drops per hour needed, which is 3,000. Per hour. Now let's divide both sides by 60 to express the rate in drops per minute. So 3,000 divided by 60, and we get 50 drops per minute. Question 27c. Ariana's parents have given her an interest-free loan of $4,800 to buy a car. She will pay them back by paying X dollars immediately and Y dollars every month until she has repaid the loan in full. After 18 months, Ariana has paid back $1,510, and after 36 months, she has paid back $2,770. This information can be represented by the following equations. So part 1, solve these equations simultaneously to find the values of X and Y. So we could use the elimination method here, or you could use substitution method. I mean, either one's fine. But I think it's easy enough to see that if we, I'm just going to label these equations, if we take equation 2 and subtract from equation 2 equation 1, we could come up then with an equation that eliminates the X, and we can just find the Y on its own, and then we can substitute it back into equations 1 or 2 to then find the values of x. Okay, so if we just do the 2 minus 1, okay, let's see what happens. So 2770 minus 1510. Okay, and we also have 36y minus 18, so we'll do both of those. So 36y minus 18y, well, it's equal to 18y. Since x minus x is 0, so that's eliminated. And 2770 minus 1510, we have 1260. So 18y is equal to 1260. Dividing both sides by 18, y is equal to 1260 divided by 18. Therefore, y is equal to, okay, divide that by 18, is equal to 70. So that's $70. That's actually y dollars per month, so she's paying back $70 a month. Now let's find the x. So from, you can pick any equation, you can use equation 1 or equation 2. Let's say from equation 1, okay, we have x plus 18y, so 18 multiplied by 70, since we've now found the value of y, is equal to 1510. Okay, let's solve now for x. 18 multiplied by 70 is 1260. So x plus 1260 is equal to 1510. X is equal to 1510 minus 1260. So just algebra now. Okay, and 1510 minus 1260, we have 250. Okay, if you can just see that there. Okay. So just summarizing the results, therefore, x is equal to $250 and y is equal to $70. So part 2, how many months will it take Ariana to repay the loan in full? So we can use either one of these two equations. It doesn't really matter. We can form our own even. We know that Ariana is paying X dollars per month. Actually, I'll just go back to the original question. She's paying X dollars, sorry, immediately and Y dollars every month until she has repaid the loan in full. And she borrowed $4,800. So let's just form another equation now. So we have X plus, okay, so this is, let's say N multiplied by Y is equal to $4,800. We have values for X and Y now. So X is the amount that she pays immediately, which is $250, plus N multiplied by, so N is the number of months multiplied by the amount that she's paying every month, which is $70 a month, is equal to $4,800. Now we need to solve for N, which is the number of months. Okay, so N multiplied by 70 is equal to 4,800 minus 250. So subtracting 250 from both sides. Okay, so 4,800 minus 250, and we get 4,550. Okay, so therefore N is equal to 4,550. We're going to divide that by 70. Okay, to get N, and we get 65. So she's going to take 65 months to repay the loan in full. Question 27D. In a small business, the 7 employees earn the following wages per week. Part 1. Is the wage of $970 an outlier for this set of data? Justify your answer with calculations. So this is based on that rule, the 1.5 multiplied by the interquartile range plus Q3 determines the boundary for an outlier. So let's work out the interquartile range first. So, there's 7 employees, so that's nice. Here's our median. Okay. Our Q3 will be here, and this will be our Q1. Okay, so interquartile range. Okay, is equal to Q3 minus Q1. Okay, and that equals 680 minus 490. Okay, so alright, so 680 minus 490, and we get 190. Okay, so the upper bound for an outlier, okay, is equal to, okay, Q3 plus 1.5 multiplied by 190, okay, and that equals, okay, so 680 plus 1.5 multiplied by 190, and we get 965. But $970 is greater than 965, so 965 will be a little bit further to the left than the 970. So 970 will be an outlier. Now, okay, is bigger than 965. Therefore, $970 is an outlier. So part 2. Each employee receives a $20 pay increase. What effect will this have on the standard deviation? So looking at the original numbers, the standard deviation measures the average distance from the mean, or wherever the mean may be. But it also measures the distance or the relative difference between the points as well. So you can sort of think of it from that perspective, that if everybody got exactly the same increase relative to each other, they're all still spaced the same. So everything has increased by $20, including the mean. So there's no effect. Okay, so there's no effect whatsoever. Okay, since they've all increased exactly the same way. Question 27E. A 42 megabyte MB file is to be downloaded at a rate of 500 kilobits per second, kbps, where 1 kilobit equals 1000 bits. How long would it take to download this file? Give your answer in minutes and seconds, correct to the nearest second. So the first thing we're going to do is convert this file size from megabytes into kilobits. Then we'll divide that answer by 500 to give us the number of seconds, and then we'll convert that time into minutes and seconds, not just seconds. So let's start. So we've got 42 megabytes. I'm going to convert that into kilobytes. So we multiply that by 1024. Okay. So there's 1024 kilobytes in a megabyte. And let's convert that into bytes. So there's 1024 bytes in a kilobyte. So let's multiply that by 1024. And there's 8 bits in a byte. So let's multiply that by 8. And so that gives us the number of bits, but we need to convert that into kilobits. So let's divide that by 1000. Okay. And let's see what we get there. So 42 multiplied by 1024 multiplied by 1024 multiplied by 8. And then we're going to divide that by 1000, and our answer will be in kilobits. So there we go. So that equals 352321.536 kilobits. So that's a small k, small b. Okay, I might just write it like this. Okay, small k, small b. So the time to download is equal to 352321.536, and we're going to divide that by 500. Okay, so let's do that, and that gives us the number of seconds, okay, which is 704.643. Okay, and that's seconds. So we need to convert that now into minutes and seconds. So let's divide that by 60 to convert it into minutes. So that's 11.744 minutes. Actually, I'll just put that there. Okay, so that equals 11.7440512 minutes. Okay. So the decimal part of this answer, we're going to convert that into seconds. So we know we have 11 whole minutes there. Okay, so that equals 11 minutes plus 0.74400512 multiplied by 60 seconds. Okay. Okay, so 0.7440512, multiply that by 60, and we get 44.64, which is around 45 seconds. Okay, so that's equal to 11 minutes and 45 seconds, correct to the nearest second. Question 28a. The diagram shows an annulus. Calculate the area of the annulus. So to donut shape, it's the area of the large circle minus the area of the smaller circle. Now, one thing to note is we have the diameter of the larger circle. We need the radius. So r is equal to 5 centimeters, and we can then use that to calculate the area of the shaded part. So that's going to be pi multiplied by large radius, or the larger radius, minus pi multiplied by the smaller radius. So that's from there to there, 3. And that's it. Well, quite straightforward. So pi multiplied by 5 squared minus pi multiplied by 3 squared. And we get 50.265. Okay, it doesn't say to round it, so I'll just leave it to 3 decimal places. Doesn't really matter. Question 28b. The results of 2 tests are normally distributed. The mean and standard deviation for each test are displayed in the table. Christoph scored 74 in mathematics and 80 in English. He claims that he has performed better in English. Is Christoph correct? Justify your answer using appropriate calculations. So what we need to do is compare the z-scores that correspond to 74 and 80, and obviously the z-score that's higher. The raw score that is represented by that z-score would then be the better score, or the highest score. So especially if we're comparing relative performance in sort of 2 different subjects, that's what we need to do. Okay, so let's work out the maths z-score. Okay, so we take Christoph's raw score, 74, and we minus the mean over the standard deviation, which is 6.5. Okay, and let's see what value we get. So 74 minus 70 divided by 6.5, and we get 0.615, or thereabouts. So 0.615. So it is sort of approximately equal to. Okay, now let's work out the English z-score. Okay, so Christoph scored 80 in English, and the mean for English was 75, and we divide that by standard deviation of 8. Okay, and we'll see approximately what that evaluates to. Okay, so 80 minus 75 over 8, and we get 0.625. Okay, so the English z-score is greater than the maths z-score. Hence, Christoph is correct. Question 28c. 3 equally spaced cross-sectional areas of a vase are shown. Now I'm going to use the trapezoidal rule to answer this question. So using the trapezoidal rule, to find the approximate capacity of the vase in litres. So first of all, it's worth noting that the areas are in square centimetres, and the distance between the areas is in centimetres as well. That means that we're going to get an estimate of the volume in cubic centimetres, and it's worth noting that 1 cubic centimetre is equal to 1 milliliter, and also that 1,000 milliliters is equal to 1 litre. Okay, so let's apply the trapezoidal rule. So we're going to need two applications of the trapezoidal rule first. So the estimate of the volume, okay, is equal to H on 2 dF plus dL, but this is going to be AF plus AL. So H on 2, so we have 15 centimeters there. So the distance between each of these areas is 15. So it's going to be 15 on 2. Okay. And actually we'll do it from from area 1, so 45 square centimeters plus 180 square centimeters plus 15 on 2, 180 square centimeters plus 35 square centimeters. Okay. And let's evaluate that expression. So 15 on 2 and we get 3,300 cubic centimeters. Okay, and that's equal to 3,300 milliliters, and that's equal to 3.3 liters. Question 28D. The formula C equals 5 over 9 multiplied by F minus 32 in brackets is used to convert temperatures between degrees Fahrenheit F and degrees Celsius C. Convert 3 degrees C to the equivalent temperature in Fahrenheit. So this question is around rearrangement, or rearranging the formula to make F the subject. So let's start off by substituting 3 for C in the formula, and then we'll rearrange it. So 3 is equal to 5 over 9 multiplied by F minus 32. Okay. Now, rather than multiplying by 9 and dividing by 5, you can do this actually in one step. So this number here, 5 over 9, or this fraction 5 over 9, is being multiplied by F minus 32. We could move this 5 over 9 over to the other side, okay, and we could do it this way. So 3 divided by 5 over 9 is equal to F minus 32. Now we'll add 32 to both sides. So this negative 32 will move over to the other side and becomes positive 32. So 3 divided by 5 over 9 plus 32 is equal to F. Okay, so just evaluating the left-hand side. Okay, so 3 divided by 5 over 9 plus 32, and we get 37.4. degrees Fahrenheit. So therefore 3 degrees Celsius is equal to 37, actually I'll just fix that, 37.4 degrees Fahrenheit. Question 28E. The shoe size and height of 10 students were recorded. Part 1. Complete the scatter plot and draw a line of fit by eye. So there's the scatter plot. And we might just have a look at part 2 and 3 quickly. We're going to use the line of fit to estimate the height difference between a student who wears a size 7.5 shoe and one who wears a size 9 shoe. And then part 3, a student calculated the correlation coefficient to be 1 for this set of data. Explain why this cannot be correct. In fact, part 3 could be in fact answered first, just by looking at these points, we can clearly see that a correlation coefficient of 1 is a perfect correlation where all the points would lie on the line. But we need to draw the line first and just show it at least. So let's do part 1. Complete the scatter plot and draw a line of fit by eye. Okay, so we've got, okay, I might just zoom out for this. All right. 6, 7, 8, 9, we got 9.5. Thankfully, the table's in ascending order, so the shoe size, so 6, 7, 8, 9, 8.5, sorry, 9.5 is there. We've got 10, 10, 1, 90, so that's another point. Okay, so there's one there. Okay, we've got 11 and 185. Okay, so that's about there. Okay, we have 12, 200, so that's another coordinate. So that's here. And finally at 12, 195. So 12, 195, so that's here. So it's possible to have the same x coordinate, but have two different y coordinates. And in fact, that happens here, shoe size of 7. Okay, that's 1 mark just for plotting a point. Now we need to draw a line of fit. It's not a line of, well, we try and make it the line of best fit. It's not going to be the best necessarily. So we draw a line such that half the points, I'll just zoom in again, so that half the points are above the line, half are below, and we also try to minimize the distance as much as possible from or between each point and the line. So I'm thinking this is where a clear ruler, in fact, is really handy. So there's no real, I guess there's no perfect answer. I think that probably would suffice there. They've got 4 above, 4 below, and I'd say that's probably, yeah, it's probably the most ideal one. In fact, I might even put it this way. Maybe between those 2 points, in fact. So I might just do that. Yep. Okay. I'll just rub that out there, so a little bit over. Okay. So that's that for 2 marks. Let's have a look at part 2. Use the line of fit to estimate the height difference between a student who wears a size 7.5 shoe and one who wears a size 9 shoe. So now we no longer use the points, we use the line. So a 7.5 shoe, so that's just here. Okay, so this is where we can project vertically from the x-axis. Okay, so that's about there. Okay, and across we have, that's 162. Okay, so that corresponds to 162 centimeters, and a student who wears a size 9 shoe. Okay, so that's easy enough there. We could just project to this point here. So once it strikes the line, we project across, and we get, well, it's roughly around 175. It doesn't have to be super exact, okay, as long as it's actually about 174. Okay, so size 9 corresponds to 174 centimeters. Okay, so 174 minus 162. Okay, and that's equal to 12 centimeters. That's the height difference. Okay, now let's get back to our part 3. A student calculated the correlation coefficient to be 1. Explain why this cannot be correct. Now we can clearly see why. Okay, you can see that the points do not lie on the line. Okay, so do not all lie on the line. So correlation is not perfect. Okay, probably have to leave it at this point. Okay, I've run out of space, but yeah, so points do not all lie on the line, so correlation is not perfect, therefore it can't be 1. Okay, and we'll leave it at that. Question 28F. A charity seeks to raise money by telephoning people at random from a call centre and asking them to donate. Over the years, this charity has found that the amount of money raised, A dollars, is related to the number of telephone calls made, N. A graph of this relationship is shown. It cost the charity $2,100 per week to run the call centre. It also costs an average of 50 cents per telephone call. So part 1, write an equation to represent the total cost, C, of running the call centre for a week in which N phone calls are made. So that one's a fairly straightforward one. C, that's the cost, is equal to, so we have a fixed cost here of $2,100. That needs to be paid basically up front. And every telephone call is going to cost 50 cents or half a dollar. So we'll leave everything in dollars, of course. So that's one of the things, just it's a subtle point, but this 50 cents really needs to be expressed in dollars because all amounts are in dollars. So we use the same units. So this will be plus 0.5 N. So part 2, by graphing this equation on the axes above, determine the number of phone calls the charity needs to make in order to break even. Okay. So this is a linear equation. This C equals 2,100 plus 0.5 N. This is the y-intercept, 2,100. Even though it's written back to front, in fact, I could write it. I'll just write it actually maybe off to the side here. I could write it like this, 0.5 N plus 2,100. So this is in the form y equals mx plus c. So gradient is 0.5 and the y-intercept is 2,100. So 1, 2, 3, 4, 5. Okay, so it looks like we're going to be starting from here. Okay. And the gradient is 0.5 n. So in other words, for every 200 we go across, we go up 100. Okay, so 1 there. Okay, for every 200 across, okay, we go up another one. Okay, 200 across, we go up another one. Okay, 200 across, we go up another one, and so on. Okay, so it's an easy way of graphing without even having to use a table of values, which is very handy. Okay, so just interpreting what it meant, what 0.5 n means. Okay, so okay, there's our line that represents cost. So this is our cost, and we need to work out where the break-even point is. So that's the point of intersection. Okay, so that's just here, and that will be 700. Okay, so 700 calls need to be made. Okay, determine the number, 700 calls. Question 29A. On 20 August, tickets were purchased for $425 using a credit card. No other purchases were made using this card in August. Simple interest was charged at a rate of 18.4% per annum. There was no interest-free period. The period for which interest was charged included the date of purchase and the date of payment. What amount was paid when the account was paid in full on 31 of August? So the first thing we need to determine is the number of days that the interest is accruing. So let's work that out as n equals, okay, so it's within the same month, so kind of makes it easy. So it's 31st of August minus the 20th of August, but because we're including both the date of purchase and the date of payment, we need to add 1 there. So 31 minus 20, so 11 plus 1 is equal to 12 days. Okay. And now we also need the daily interest rate. So the interest rate is quoted as 18.4% per annum, but because we're dealing with n measured in days, so that's the number of periods, or the length of a period is 1 day, we need the interest rate per day. So that's going to be 18.4% over 365. And I'm not going to evaluate that. We don't need to. We can just leave it in that form. So now let's work out the interest. Okay, so I is equal to PRN, P times R times N. Okay, so I is equal to the principal P, which is $425. Okay, multiplied by the daily interest rate. So that's 18.4% over 365, and multiplied by the number of days. We've got 12 days. So that's going to be equal to, okay, let's work this out. Okay, we'll evaluate this expression. So 425 multiplied by 18.4%. Make sure you type in the percentage symbol. Okay, over 365, and we'll multiply that by 12 days. And we get $2.57, so to correct to the nearest cent. So total paid is equal to $425 plus $2.57. Okay, so plus 425, and we get $427.57. Question 29b. Jamal borrowed $350,000 to be repaid over 30 years, with monthly repayments of $1,880. However, after 10 years, he made a lump sum payment of $80,000. The monthly repayment remained unchanged. The graph shows the balances owing over the period of the loan. So over the period of the loan, how much less did Jamal pay by making the lump sum payment? So I think first thing to note is the saving. So just this part of the graph here. So normally it would have taken 30 years, but by making this lump sum payment of $80,000, Jamal saved 8 years worth of loan repayments. So we work out the 8 years worth of loan repayments. We then subtract the $80,000 from that, because think of it as an investment. Jamal paid an extra $80,000 to save, hopefully, what is going to be more than $80,000. And so the net saving should be, hopefully something substantial. So let's work that out. So the saving, okay, is going to be, we've got 8 years worth. Okay, so that's the difference between obviously 22 and 30 there. The payments are monthly, so we have 12 months in a year, so it's 8 lots of that. And each one of these payments is $1,880. Okay, but that's not really the net saving. The net saving, we need to take into account his investment of $80,000, so this extra payment that he made. So taking away 80,000, so let's evaluate this expression. Okay, so 8 times 12 times 1,880 minus $80,000, and we get $100,000, so $100,480. Yep. And that's his saving. Question 29c. The image shows a rectangular farm shed with a flat roof. The width of the shed indicated by the dotted line was measured using an online ruler tool and found to be approximately 12 meters. Part 1. By measurement and calculation, show that the area of the roof of the shed is approximately 216 square meters. So we need to come up with a scale first of all. So we're told that the diagram is to scale, the photograph is to scale. Okay, so we can see there that 40 millimeters corresponds to 12 meters in reality. Okay, so And let's write the scale there. In fact, okay. In fact, I'll do it as an arrow there. So scale is equal to 12 meters. So that's the width of the shed. So let's work out the length based on that scale. Okay, so we can see there that the length of the shed is 60 millimeters. Okay, is 60 millimeters, but we divide it by 40 millimeters, then multiply it by 12. So this is the unitary method. Okay, and then we multiply that by 12, and that gives us then the real life length of the shed. So 60 divided by 40, and we're going to multiply that by 12, and we get 18, so that's 18 meters. Okay, so area is equal to 12 multiplied by 18. Okay, so therefore, so 12 times 18, and we get 216. As required. Okay. Part 2. All the rain that falls onto this roof is diverted into a cylindrical water tank which has a diameter of 3.6 meters. During a storm, 5 millimeters of rain falls onto the roof. Calculate the increase in the depth of water in the tank due to the rain that falls onto the roof during the storm. So the first thing we need to do is to work out the volume of water that's fallen. So we're going to work that out in cubic meters. Okay, so volume is equal to AH. Okay. And we have our A is equal to 216. So that's what we worked out previously. In fact, we're given that anyway, even if you couldn't work out part 1. And our H, okay, is the depth of rain, which is 5 millimeters, but we need to convert that into meters. So that's going to be, okay, so 5 divided by 1,000, so that's converting millimeters into meters. Okay, so 5 divided by 1,000, and we get 0.005. Okay, so therefore the volume of rain, okay, is equal to 216 multiplied by 0.005, and that gives us 216 multiplied by 0.005, and we get 1.08 cubic meters. Or that's 1.08 kiloliters, or 1,080 liters of water. So for the next part, this amount of water, so just over a cubic meter, is going to be diverted into a cylindrical water tank. Okay, so, and the diameter of the water tank is 3.6 meters, which means immediately we need to convert that into radius. So we're going to divide that by 2. And we're going to use basically the same formula again, volume equals AH, but this time, instead of a rectangular prism, okay, we're going to be dealing with a cylinder instead. So that's going to be pi r squared times h. Okay, so okay, volume of cylinder. Okay, so that's going to be V is equal to pi r squared h. Now, we have the volume already. Now, this is not the volume of the entire cylinder. This is just the volume of water in the cylinder. So I just couldn't fit that there. So volume, we got 1.08. Okay, so 1.08 is equal to pi multiplied by r squared. So if the diameter is 3.6, the radius is 1.8. okay, squared, multiplied by h. And we're going to make h the subject of the formula. So h is equal to 1.08 divided by pi divided by 1.8 squared. And we'll enter that expression into the calculator and see what we get. Okay, so 1.08, we're going to divide that by pi, and we're going to divide that again by 1.8 squared. And we get 0.1061. Okay. And sometimes it helps just to go back over the question quickly. It says calculate the increase in the depth of water in the tank due to the rain that falls. It doesn't actually say to round it, but 2 decimal places is fine. I'm going to quote it in meters and also in centimeters as well. So that's approximately 10.61 centimeters. Question 29D. Data from 200 recent house sales are grouped into class intervals and a cumulative frequency histogram is drawn. Part 1. Use the graph to estimate the median house price. So we have a frequency of 200. So the median would be the halfway mark. So it'll be where the 100 is. So where the frequency is 100. So what we'll do is we'll just project across first. So where on the y-axis where it's 100, we'll just draw a horizontal line across. Okay. And then what we'll do is that we'll draw part of the ogive on the third column, because clearly that's where it's going to intersect with the horizontal line that we just drew. So, okay, so we'll just do that there. Okay. And where these two lines intersect, that's an estimate of the median. So we could actually use this part of the grid here where it's visible. Okay, so we need, that's our point of intersection just there. Okay, and it's going to be roughly, okay, and like I said, it is just an estimate, so it doesn't have to be super accurate, but you know, sort of accurate enough for our purposes. So something along those lines there. So I'll just zoom in a little bit further on that. Okay, so we need to estimate roughly what this point is here. So, okay, if that's 390 to 400, why don't we just measure that? How many centimeters that is. So that's 15 millimeters, and we've gone 4 millimeters in there from the 390 mark. So, okay, so that would be, okay, so 15 millimeters is equivalent to about equivalent to $10,000. Okay, so 10,000 divided by 15 millimeters. So that's the dollar, sort of the value per millimeter on the x-axis. Multiply that by 4, and we then add that to 390. Okay. And we get around $393,000. Okay, so okay. So basically, the working out predominantly is on the graph itself. Okay, so as long as you show those lines, that's generally sufficient. It's only worth 1 mark, so as long as you get the right answer, that's fine. So part 2, by completing the table, calculate the mean house price. So we need to basically convert this cumulative frequency graph into just a histogram, a frequency histogram. So I think this first column here, so this first class, so this is the 370 to 380 class. So let's write down the class center. So that's going to be the 375,000, sort of that group, the $375,000 value group. Okay, and then the next one will be 385,000, 395,000, and then 405,000. So I might as well fill out this table. So 375, 385, 395, and then we got 405,000. So just be mindful so that these numbers represent thousands of dollars. Now let's fill in the frequency column. Okay, so we know that the total's got to be total's got to be 200 if we add up all the frequencies. So we know that the first class, okay, of house sales, okay, the $375,000 class, okay, there's the frequency there. So it's going up in tens, isn't it? So 50, 60, 70, 80, 90. So each of these little squares represents 10, a frequency of 10. Okay, so that'll be that's 40 there. Okay, so that'll be, actually no, that'll be 0. So 10, 20, 30, 40, 50. Yep, so that'll be the 0. So just be careful. The x-axis, just because of that symbol there, the x-axis does not start at 0, but the y-axis does. So just be very careful there. Okay, so just be mindful of that. Okay, so we've got 10, 20, 30. Okay. So this is where a lot of the work is, in fact. So there's 30 homes or 30 houses at that in that class. Now the next one along, so this class here, that's 80. Okay. But the frequency is not 80. That's the cumulative frequency. That also includes the 30. So it's going to be 80 minus 30. So that'll be 50. Okay. Now the 395. So that's this column here. Okay, that's 150. That'll be 150, 150 minus 80. Okay, that'll be 70. So we'll fill that in here. And the last one, well, we know it's 200. So in total, 200 minus 30 minus 50 minus 70. And just fix that quickly. And we get 50 as well. So okay, now to work out an estimate of the mean, or the mean house price, we can create a sort of an FX column there, and we can just multiply these together, these two columns together. So 375. Now remember, this is thousands of dollars multiplied by 30. Okay, and we get 1, 1, 2, 5, 1, 2, 3, 4. Okay, the next one along, okay, is the 385. Okay. And that occurs 50 times. Okay, 1925, 1, 2, 3, 4. Okay, I've just chosen to write the answers there in full. Okay, it's just easier to work with. Okay, 395, and that occurs 70 times, and we get 2765, 2765, 1, 2, 3, 4, and then we got 405 times 50, 405,000, and there's 50 of those, 2025. Okay, so the mean is we add up the FX column and then we divide it by the frequency. Okay, so mean is equal to the sum of the FX column, so 1, 1, 2, 5, 0, 0, 0, 0, plus 1, 9, 2, 5, 0, 0, 0, 0, plus 2, 7, 6, 5, 0, 0, 0, 0, plus 2, 0, 2, 5, 0, 0, 0, 0, and we're going to divide that by 200. Okay, and that'll be the mean. So let's do that. Okay, so 1125, 1, 2, 3, 4, plus 1925, 1, 2, 3, 4, plus 2765, 1, 2, 3, 4, plus 2025, 1, 2, 3, 4, 4 zeros. Divide that by 200, and we get 392,000 as our mean house price based on that data. Question 29E. A diver springs upwards from a diving board, then plunges into the water. The diver's height above the water as it varies with time is modeled by a quadratic function. Graphing software is used to produce the graph of this function. Explain how the graph could be used to determine how high above the height of the diving board the diver was when he reached the maximum height. So I think there's 2 points here to note. Okay, we have the y-intercept, which is 8, so that's 8 meters. So that implies here that the diving board is 8 meters. So why don't we start off with that? So okay, and just before I continue, why is that of importance? The x-axis represents time. Okay, so the y-intercept equals 8, which means that is the initial height of the diver. Above the water. Okay. In fact, I might just put here 8 meters. Now, the other point here that's of importance is the vertex. Okay, so this is the peak of the graph, or the peak of this parabola. Okay, just here. So that's roughly at the half second mark, or the 0.5 second mark. And we can see that it's around, probably around the 9.2 meter mark. So the vertex, okay, is at 9.2 meters. The difference then between the vertex and the y-intercept gives us how high above the diving board. Okay, which is 1.2 meters above the diving board. Question 30A. The energy consumption of a computer in standby mode is 21 watts. The cost of electricity is 31 cents per kilowatt hour. A school computer room has 20 computers. How much will the school save by switching off all 20 computers during the 11 weeks of school holidays? So going back now, just looking at various bits of data in the question. The first one is each computer draws 21 watts. We work in kilowatts when we're dealing with energy consumption and energy cost. Also, the cost is in dollars, not in cents. So there's just two things to be mindful of here. And we have 20 computers. So let's calculate the energy consumed. And that's also over the 11 weeks of school holidays. So we need to work out, basically, it's kilowatt hours. So we need to work out total number of hours over the 11 weeks. So energy consumed is equal to, we've got 21 watts, but we need that in kilowatts. So let's divide that by 1,000. Okay, so that's 21 watts divided by 1,000, converts it into kilowatts. Now, we have 20 computers. So there's the times 20 there. Okay, and that's for 24 hours a day times 7 days per week times 11 weeks. So calculating that, or just evaluating that on the calculator. Let me just brighten the display just a little bit there. Okay, so 21 watts divided by 1,000, converting that into kilowatts. Multiply that by the total number of hours. So there's 20 computers, and they're on standby for 24 hours a day, 7 days a week for 11 weeks. And we have 776.16 kilowatts. Okay, actually kilowatt hours, sorry. We just need to convert that into an actual cost though. So the actual energy cost, okay, is the energy consumed, 776.16 kilowatt hours, and then multiply it by the cost per kilowatt hour, which is 31 cents, or in dollars, 0.31. Okay, so we can take our last answer, so just multiply by 0.31, and we have $240.61 saved. Question 30b. On a tray, there are 12 hard-centered chocolates, H, and 8 soft-centered chocolates, S. 2 chocolates are selected at random. A partially completed probability tree is shown. What is the probability of selecting one of each type of chocolate? Okay, thankfully, this one's very straightforward. So if the probability in the first draw of picking a hard-centered chocolate is 12 on 20, to pick a soft-centered chocolate should be then the complement of 12 on 20. So should the two probabilities in each stage should add up to 1. So it's going to be 8 on 20. Since there are 12 hard-centered chocolates, 8 soft-centered chocolates, and out of a total of 20 chocolates. Now, we've drawn one of the chocolates out. How many chocolates are there left? There should be 19 because it's without replacement. So even though it doesn't say without replacement, it's assumed. 2 chocolates are selected at random. You don't put the chocolate back, right? So it's going to be now out of 19 for the remaining chocolates. Okay, because now there's 19 chocolates left, okay, in the box or in the tray. Now, if we've selected a hard-centered chocolate, so from there were 12 originally, how many do we have left? We've now got 11. So 11 out of 19, that leaves us 8 out of 19 soft-centered chocolates. This is for the second draw now, or the second stage. Now, likewise, for the first pick or the first stage being a soft-centered chocolate, we've had 8 soft-centered chocolates to begin with. We've chosen one of these, then you've got 7 left. That leaves 12 hard-centered chocolates then to choose from. So I think a lot of the work is in just completing the probability tree. Once you've done that, let's now proceed to answer the question based on the conditions given, or whatever the favoured event is, which is selecting one of each type of chocolate. That means we can either have a hard-centered, soft-centered, so let's just put an asterisk there, or we can have choose a soft-centered and then a hard-centered chocolate there. So these are the two probabilities. So the probability of a H, HS, or SH, okay, hard, soft, or soft, hard, okay, is equal to, now we multiply along the probability, along the branches of the tree. So we'll do the HS first, so that's going to be 12 over 20 multiplied by 8 over 19 plus SH. So 8 over 20 multiplied by 12 over 19. Okay, so let's evaluate that and see what we come up with. Okay, so 12 on 20 multiplied by 8 over 19 plus 8 on 20 multiplied by 12 over 19. And we get 48 over 95. And that's approximately equal to, so we're going to convert that as a percentage. It doesn't actually say in the question to answer in percentage form. Always answer in fraction form, but let's just convert it into a percentage anyway, just to sort of get an idea of what this is. So it's around 50.5%. Okay, so which is roughly 50.5% chance. Question 30C. The table gives the present value interest factors for an annuity of $1 per period for various interest rates R and numbers of periods N. Part 1. Oscar plans to invest $200 each month for 74 months. His investment will earn interest at the rate of 0.0080 as a decimal per month. Use the information in the table to calculate the present value of this annuity. So just interpreting this table first of all, so this means that for every dollar invested per period, so this is we're working per month. So if you're investing $1 per month, let's say for 74 months, so that's the information in the question. So we're going to be referencing this row, and it's going to earn interest at 0.0080, which is this column. Okay, that column there. So that means then that the present value of $55.68446 will be required to give you the same future value as investing $1 per period for 74 periods or 74 months. So all we need to do is take the 55, okay, 68446, and instead of $1 per period, Oscar is investing $200 per period. Of course, each period in this question is a month, and the present value that's equivalent to this investment is 55.68446 multiplied by 200, and we get $11,136.89. So 11136.89. So Oscar could invest this amount of money up front at this interest rate per period, and you'll end up with the same amount of money in the end at the end of 74 months. So moving on now to part 2. Lucy is using the same table to calculate the loan repayment for her car, for a car loan. Her loan is $21,500 and will be repaid in equal monthly repayments over 6 years. The interest rate on her loan is 10.8% per annum. Calculate the amount of each monthly repayment correct to the nearest dollar. Okay, so first of all, let's convert the interest rate per annum into an interest rate per month, since we're talking about monthly repayments. So let's do that first. Okay, so 10.8 divided by 12, okay, 0.9. Let's divide that by 100 to convert it into decimal. So that's 0.009. Okay, so R is equal to 0.009. So clearly we can see which column to use in the table as well. Okay, and it's going to be paid over 6 years. Okay, so the N is 6 years, 12 payments per year, so that's 12 months in a year. Okay, and that'll give us 72 or 72 months. So we need to use this row here, okay, and this column here. So this is the other one that we need. So I might just put an asterisk there. Okay. Okay, so that's the interest rate that we've just calculated there. So, okay, so the present value interest factor, okay, is equal to, that's 52.82118. I'll just write it here, 52.82118. Okay, so that's it there. Now, 21,500 is a present value, or the total present value. That's kind of like an investment, but it's sort of a loan. It kind of works in reverse. So the monthly repayment is equal to this present value. Okay, so 21,500, okay, which is the amount borrowed, divided by the present value interest factor, so 52.82118. Okay, so let's evaluate that. So 21,500 divided by 52.82118, and we get $407.03, and that's per month. Question 30D. Claire is driving on a motorway at a speed of 110 kilometers per hour and has to brake suddenly. She has a reaction time of 2 seconds and a braking distance of 59.2 meters. Calculate her stopping distance. Now, any kind of stopping distance question, advisable to draw a number line. And stopping distance is composed of two parts. Okay, you have the reaction distance, and then you have the braking distance. And the sum of those two gives you then the stopping distance. Now, we already have the braking distance given, which is 59.2 meters. But we don't know what the reaction distance is. So once we've got that, we can then go on to calculate the total stopping distance. So the reaction distance is in meters, 110 kilometers per hour for 2 seconds. So let's convert 110 kilometers per hour into meters per second. And there's a bit of a shortcut here. Okay, if you divide that by 3.6, that gives you the speed in in meters per second. So 110 divided by 3.6, and you get 5 recurring, which is 30 and 5 on 9. And that's meters per second. But just for your benefit, just so you can see, for those of you, if you find that a little bit confusing, 110 kilometers per hour, okay? If you multiply that by 1,000, okay, that gives you the number of meters. So that's 110,000 meters per hour. An hour is 3,600 seconds. So if you divide that by 3,600, you then get the same answer. So this just is a bit of a time saver. Okay, so that's meters per second. So the reaction distance is equal to the speed in meters per second multiplied by the number of seconds. So that's the distance is equal to speed multiplied by time. And that's for 2 seconds. So I might just multiply my previous answer here by 2. And we get 61 and 1/9 of a meter. So the stopping distance, okay, is equal to the reaction distance. I might just do that first. 61 and 1/9, sort of kept it in exact form, plus the braking distance, 59.2. Okay, so I'm just going to again use my previous answer, and I get 120.31. And I'll just round it to 2 decimal places, and that's the approximate. That's the stopping distance correct to 2 decimal places. Question 30E. From point S, which is 1.8 meters above the ground, a pulley at P is used to lift a flat object F. The lengths SP and PF are 5.4 meters and 2.1 meters respectively. The angle PSC is 108 degrees. So part 1, show that the length PC is 6.197 meters, correct to 3 decimal places. So this one we can see that it's clearly going to be the cosine rule. Okay, so we want PC here. So we're not focusing on this right angle triangle, we're focusing on triangle PSC. We have an angle and we have 2 sides about that angle. So 2 sides and an included angle. This is going to be the cosine rule. So PC is equal to, I'm going to do this all in one step in fact, the square root of, and then we're going to apply the cosine rule. So that's going to be 5.4 squared plus 1.8 squared minus 2 times 5.4 times 1.8 times cos of 108 degrees. And I've just taken the square root of the whole lot because, as you know, with cosine rule, it's a squared equals b squared plus c squared, so on and so on. So I'll just take the square root and do it all at once. Okay, so 5.4 squared plus 1.8 squared minus 2 times 5.4 times 1.8 times cos 108 degrees, and we get 6.197 as required. I'll write as required. You don't have to, but because you're asked to prove it, so and there's the requirement to prove. So that's it for that for part 1. Part 2. Okay, calculate h, the height of the object above the ground. So it's this there. Okay, or this height there. Okay, now we have PC, and in fact I might just write this measurement, the one that we just worked out before. In fact, it's even given to us. So there's 6.197. We have a right angle triangle there, so I'll just make that a bit more apparent. And we just need really another angle, okay? And we could then work this out. Okay, so if we can find another angle. So if we can find this angle here, and I know that we can then find this angle here, and then we can use regular right angle trigonometry. So that's the thinking process. So as you're attacking this question, you need to say to yourself, well, I've got a right angle triangle here. I need another angle. I can then work out PE, this length PE. I then take away 2.1, and then I'll have H, this remainder there. Okay, so what we'll do is I'm going to put an angle there. Let's call that angle theta, and I'm going to call this one here angle alpha. So the goal is to find this angle alpha there. Okay. In fact, we've got 5.4, which is opposing alpha. We can use the sine rule here. Okay, so when you have side angle pairs, so 6.197 is opposing this 108, 5.4 meters is opposing this theta, we can use the sine rule. So let's do that. Okay, so what I'm going to do is I'm just going to define theta first of all. Theta equals angle PCS. So I'm just going to write that down first, PCS. Okay, so by the sine rule, okay, we have sine of theta. Okay, so back to the diagram, sine of theta over 5.4. Okay, is equal to sine of 108 over 6.197. Okay, we'll just use that rounded number, the answer that we got in the previous part. So now we need to just make theta the subject of the formula. Okay, so just to save a bit of space, I'm just going to continue it on to the next line. Sine of theta, we're just going to multiply both sides by 5.4. So that's equal to 5.4 multiplied by sine 108 over 6.197. And then we just make theta itself the subject by taking the inverse sign or shift sign of the right hand side. So theta is equal to inverse sine, just try to save a bit of space here, of 5.4 sine 108 over 6.197, and I'm just going to answer to the nearest minute. Okay. So shift sign, and 5.4 sine of 108 over 6.197. Forget the close brackets there. Okay, and we get 55 degrees and 58 minutes. Okay, so that's this angle there. So this angle there. Okay, 55 degrees, 58 minutes. So theta, okay, so let theta equal, and that's going to be ECP. Okay, and moving on, okay, theta is equal to 90 degrees minus, okay, minus theta. Okay, so 90 minus my previous answer, and that's going to be 34 degrees and 2 minutes. Okay, so now we have enough to be able to answer this question using basic right angle trigonometry. So I'm just going to write this, a bit of information on the diagram. So there's 34 degrees and 2 minutes. Okay, now we can find length PE. Okay. So we have an opposite side, okay, and we have a hypotenuse. So we need to use the sine ratio there. Okay, so sine of 34 degrees, 2 minutes is equal to PE over PC. Okay, so over PC, so it's going to be 6.197. Okay, and PE is equal to 6.197 multiplied by sine 34 degrees. Hopefully I can just make it in that between just before I get to that margin. Yep, and I just do. Right. So let's evaluate this one. 6.197 multiplied by sine 34 degrees, 2 minutes. And we get 3.4683. Okay, so that's this whole length here, PE. So H, which is got to subtract 2.1 from that answer. Okay, so H is equal to 3.4683 minus 2.1, which is 1.368. And that's it to 3 decimal places. In fact, just rounding it straight off the calculator screen there, I think we can just leave it at that. And that's meters, and that's correct to 3 decimal places.